So here it is. Maybe I should have changed the hashtags. I put break time is over. And well, yeah, because it is the end game. Like this is. No. This is our end game. So maybe okay. I'll switch to the hashtags tomorrow, guys. Um, I printed out the notes in colored copy, and look what they're doing here. It's saying that they're seeing there's some three-dimensional model, and they're cutting it. And what they're doing here is that we're adding up an infinite amount of cross sections, and that's how we're getting the volume. So I know that you guys can't really see, but I guess. All right, so look at the Chavez little screen right now. I guess click on like view or whatever. Do you guys see this one sheet here that I'm holding on the camera? That I'm like, okay. So this one sheet, it's practically volumeless. Do you guys agree that the volume of this is practically zero? Okay, now imagine if I keep adding an infinite amount to form, or an infinite amount of cross section. Look, here's a cross section. Hey, Tiff, can you hook me up with one of those? What do they call them? Like bales or something? Yeah. Sorry. So if I keep adding, obviously, look, this is not calculus related because it doesn't change in size. But if I keep adding, if I put 500 of these, then I'll get something like this. And this has girth to it. This definitely has volume. Thickness. This has thickness to it, guys. So notice that. Whoa, almost. Yeah, everything's going on wrong. Notice that this time I do have volume, right? So that's the concept. We're just adding an infinite amount of cross sections. Does that make sense to you guys? Okay. Yeah, this is a cross section, but we got to have a common cross section. So that's the whole point. We got to have a common cross section, guys. So that's how they're doing. And then see, look, all they're doing is they're integrating that common cross section an infinite amount of times, or they're adding up the cross sections an infinite amount of times. So if you want to put that for notes here, adding up an infinite amount of cross sections. Because one cross section is an area, right? Now it needs to be a common cross section, guys. So we got to look for geometry on it. Like, what's a common cross section? You cannot have different types of shapes. Like, one cross section cannot be a circle and the next cross section a rectangle. It needs to be all the same shape. That's the whole point. That's the whole point behind it. So as you can see here, hopefully you can see that outline in blue. That cross section is the same as this very last one here at that endpoint, and it's the same as this one. You can't really, but yeah, it's the same. Yeah, even if it's a different size, you're still adding an infinite amount of cross section. Consider like a square pyramid, like all the base is a square, and if you keep slicing and adding up all those slices all the way to the very top of the square pyramid at the point, they're all squares anyways, and you're adding them all up, and all that will add up to a volume. Does that make sense? Okay, and don't worry, I'm going to use technology to show you how this is going to look. So let's look at example 1. A mathematician has a paperweight made so its base is the shape of a region between the x-axis and one arc, ARCH is how they spell it, but arc of the curve y = 2 sine x. Each cross section cut perpendicular to the x-axis, and hence the xy plane, is a semicircle whose diameter runs from the x-axis to the curve. Find the volume of the paperweight. Okay, so this line that I have right here, consider that you have a semicircle coming out of that paper. And you can see it, here's the image, and you have an infinite amount. So I can tell some of you guys are like, well, how does that even look? Well, I got you. Look, before class started, I took out something called WinPlot, which is a free software. Now, some of the laptops, guys, if you don't have a strong enough processor, it's not going to be able to process that. So let me show you what I'm talking about. So hopefully you guys can see that right here. So check it out. This is that cross section, y = 2 sine x, and I don't know if you can see that blue line down there. And here's what I'm going to do. I'm going to get cross sections. So I'm going to go to sections. and y equals 2 sine x to y equals 0, and I want them to be semicircles. So this height doesn't matter here. And I want the low to be 0. And I want the high to be, was it, what was it? Was it pi? Yeah, pi. Pi. And there we go. And I'm going to code C solid. So check it out, guys. So let me see if I can show you guys. Oh, man, can I? Okay, I'm going to have to take out this keyboard here. There we go. Let me see. Can you guys see that solid more or less? Probably not, right? See, there it is being rotated. And I don't know if you can see the x-axis is like right there. That's the x-axis. And I'm trying to see if I can find the little up and down. Made you dizzy? I'm sorry, miss. I'm trying to find the up and down. Oh, man, do I not have up and down? Let me see, animate. Trying to animate it, guys, but view axis. All right. Why can't I move it? Well, I didn't think this through, guys, as you can see. So look, there it is. There's a better view. There's the x-axis right here where this arrow is. That's the x-axis. And here's the y-axis. And then they have the z here. That's coming out of the paper. See? And it kind of looks like a dome, like a weird shaped dome. Kind of cool, right? Oh, you guys don't like it? I think it's really cool. See, there it is. I think they're coming out of the paper. They're going from the x-axis to the y equals 2 sine x. And that is the diameter. That makes sense? And as you get closer and closer to the endpoints, the semicircles are getting smaller and smaller. Cool or not cool? All right, let's get back to this guy. And let's see, did it change? Yeah. All right, so you can see there, guys, they show you 1, 2, 3, 4. They show you 5 cross sections. The hardest part of volumes is figuring out the area of the cross section. That's the hardest part. And then once you know that, that's where you're going to integrate an infinite amount of cross sections, guys. So here we go. A of x. I need my cross section. This is a diameter, so I'm looking at this big one right here. I'm looking at that big cross section to help me out. So area of a semicircle is pi r squared divided by 2. Of course, I want it in terms of x, not r, right? So here it is. A of x equals pi, parenthesis, the radius. Well, the diameter is the distance from the x-axis to this curve. And if I take that and divide it by 2, will that give me the radius? Yes. So there it is. And I'm going to square that, divided by 2. Let's simplify it, guys. Don't leave it like that. The 2's cancel out. I get pi sine squared x divided by 2. There it is. That is what you're going to integrate. So I come over here. They want the volume. So I'll write volume. And I'll slow down because I can see some of you guys. Volume in terms of x is equal to the integral from 0 to pi of this expression. Now there's a constant that I can take out, guys. So I'm going to take it out. Oh, pi. And then all I have to integrate is this. You're not going to do these by hand. That's the good part. Most of the time, it's all done with a calculator. So let's take out the calculator here. So everyone take out your calculator. Where are you? 284. Okay, first, make sure that you are in radian mode. And yes, I'm in radian mode. So I'm gonna push math number 9, and I'm gonna go from 0 to pi. Oh, and I already forgot something, huh? I forgot to put the yeah. So I'm gonna go back to the outside of this. Second insert, pi over 2. And if you want to use the fraction feature, you can. You know what? I'll make it look like that. Delete, delete, delete. Second insert, alpha y equals. To get the fraction, you got to push alpha y equals. And there we go. Second pi over 2 from 0 to pi. And then I'm going to type in parentheses, I'm going to open up another parenthesis. And I'm going to put sine x close, and put a square on it. If you are scared, and I'll show you right now in a little bit. So 2.467. If you are scared, guys, because that looks very similar to like x squared, it's not, it's sine squared. But if you're scared, you can always go to y equals, type sine x in here. And then look, go to the home screen again. And you can just go alpha y equals, and then, sorry, what did I do? Alpha y equals. What did I do? Alpha y equals, enter, pi over 2. And then math number 9. And then 0 to 2. And then right now I have it in y1. Oh, 0 to pi, sorry. Second pi. And then I'm going to go alpha trace y1, and I put a square on it. And it should be the same answer. Bam. And there it is. So the answer is 2.467. You're always welcome to write more digits. And there it is. How do we feel, guys? Yes. Remember when we were doing area under the curves, and I wanted to figure out what the area of this curve was? And then first we started off by doing like rectangles, and we added up all these rectangles. First, this is the estimate. That's how we did it. And then we said, okay, well, how do we add an infinite amount of rectangles? And then we did this. So don't write this down, guys, just listen. And I'm gonna say that's 0, I'm gonna say that's a. 0 to a, and then this is f of x, and then dx. So the f of x was the function, the height, and the dx was the width. All right, so, and then we understand that that means infinite amount of rectangles, right? Okay, same concept. But this time we're not adding rectangles, we're adding an infinite amount of cross sections. So, I'm sorry, say it again? Which is a shape, a common shape. So let's look at this picture here. I'm adding this cross section. I'm adding this cross section, I'm adding this cross section, I'm adding that cross section, and I'm adding all the cross sections, an infinite amount of them. And then how do I get the area of the, well, this is the area of a cross section. And do you agree that volume is that cross section times whatever the width of that little cross section may be? So that's exactly what this is right here. The area times the width will give me the volume. Does that make sense? Okay. All right, guys. So now let's go on to example 2. So the hardest part of this, the hardest part is just finding the cross sections. So that's why I went ahead and just put a whole bunch of cross sections here. So it says, for example, for A through D, find the formula of A of x, just a cross section. For the solids that are perpendicular to the x-axis, the solids lie between the planes perpendicular to the x-axis at x equals 0, at x equals 4. The cross sections perpendicular to the x-axis between these planes run from y equals negative square root of x to y equals square root of x. So what you're looking at, notice that's the x-axis, notice that's a y-axis. So this line up here in red, that is y equals square root of x. This line down here in blue, that is y equals negative square root of x. And if I were to do it, they did a 3-dimensional plot, guys. Here it is in 2-dimensional. In 2-dimensional, I just look like this. Are we okay so far? Okay, I'm gonna try to go slow, guys. So what you're looking at right now is 3 cross sections. Cool or not cool? So what you're looking at is 3 cross sections. So I like to write like one random cross section somewhere. So here it is. That's my cross section, and I'm gonna try to visualize it. It doesn't look like that, but more or less. Where the center here is that cross section. See, that center is this part right here. And let me erase all these little markings so it's easier to see. Okay, what's the area of that cross section? So here's what I tried to do, guys. I tried to do just this one circle there. So area of that cross section is, that's a circle, pi r squared. You don't want it in terms of r, I want it in terms of x. Pi, the radius, the distance from the x-axis, let me outline it here in black, x-axis to that curve. So that radius, remember what the top curve was? Wasn't that square root of x? Right? So pi times square root of x squared. Well, if you square it, it's going to be back to a positive anyways. You're saying like the other part, the other half, always work with what you think is easier. Yeah, you could have done from the x-axis to the negative square root of x, but no, because that's my radius. You're talking about like, okay, you're saying this whole distance, that's a diameter. That would have been 2 square root of x. But I don't want the whole thing. I just want the radius, which is this in blue. That distance is just y equals square root of x.
But if it's negative, like if the y values are negative, does that still add to the volume?
Yeah, if so you're saying if I would have taken this one here, that one, or it's because there's no way to get a negative because I'm adding all up. You know what I mean?
Remember how like whenever we put on the math,
Uh huh.
the radius of a graph is like all of this, the ones under the x-axis is the positive.
Yes.
You have to do that too.
If yes, you do. You have to. Okay, you're gonna have a problem right now where this is gonna be a square, and we're gonna have to figure out that length, and we're gonna have to take that negative into account. But it's a very simple process. You'll see it right now. You're getting ahead of me. Yes.
But do you have to use the radius of the bigger cross section?
It doesn't matter. They're all the same. If I look at this one here in black or blue, remember, we don't know where that cross section is at. So here's my diameter of that one in blue. And where's the radius? The radius is from the x-axis to that curve. So it's still going to be square root of x. I use a cross section that I think is the easiest. So I always look at the biggest one. You know what I mean? All the cross sections are circles, all of them. Okay, there it is. We're done. If you wanted the volume, they had to tell you like an endpoint. Find the volume between 0 and something. If you're wondering how this looks like, it kind of looks like a football, but that never ends, that it just keeps getting bigger and bigger and bigger. So I guess not like a football. I don't know what you would call it. Like the shape, okay, I see the visual right here. I got a perfect one. The cone or the nose of a plane, of one of those big planes. This is what that would look like. Just the nose part. But keeps getting bigger and bigger and bigger and bigger. Do you guys see that? Okay, I think it's really cool. All right, check out this one, miss. So this is the one that you were talking about. The cross sections are squares with the bases on the XY plane. So now, how do I figure this out? I need this distance. There's 2 ways to do it. Remember, guys, this top one is still y equals square root of x. And this bottom one here is y equals negative square root of x. They just went ahead and wrote x equals y squared because it's easier to just write it in one like that. I can do one of 2 things. Either you recognize I wanted a whole length, and this is a square, right? So how do I get area of a squared? Side squared, correct? So upper minus lower, I can say parenthesis, square root of x minus a negative square root of x, close, and then put a square on it. So you get 2 square root of x squared. So finally you get 4x. That's one way to do it. Or you can recognize, you can say, so here it is, guys, don't write anything down, just listen. You can recognize, well, the distance from here to here, that's square root of x. So that means the other distance must be another square root of x. So you could say, oh, okay, ax equals 2 square root of x, close it squared, if you recognize that. And you can go right to it. It doesn't matter how you do it. If the logic is correct, you will be fine. Did that make sense? Did I answer your question from before? Okay. Guys, virtual, did all this make sense to you or no?
Wait, why did you do the upper minus lower?
Oh, because I know because of this right here. So maybe this one will help you. So check it out. So this cross section right here, that's this part of the square. That's this part right here. And because I want to get a side, like remember, it's coming out of the paper. I want to figure out what that length is. So this top part is y equals square root of x, this curve here. And this bottom curve is y equals negative square root of x. So if I want to figure out the length of this black line, I got to do square root of x minus negative square root of x to figure out this length right here. So square root of x minus a negative square root of x. Does that make sense? It's like if you were finding area under the curve. If I told you, find this area here. Well, the top curve is square root of x, the bottom curve is negative square root of x. So you would do upper minus lower, and then you would integrate from 0 to whatever that x coordinate is. That makes sense or no?
Yeah.
Okay. We're good? Okay. All right. Now we're getting interesting. The cross sections are squares with the diagonals in the xy plane. Oh man, Chavez, I don't have a visual. How am I going to do it? Here's how I do it, guys. Remember, I got a D in art, so I'm not the best drawer. Here's how I do it. I draw the original equation in 2 dimensionals. Here it is in 2 dimensional. And then I do a cross section. I just go, bam, there's one cross section. And then I think about it visually. I go, well, here's a square. That's a square. And I'm trying to color code it, guys. But this black line is the diagonal of this square, of this cross section. So there's my diagonal. That black line that I do here, the diagonal, is this line here. So half of it is coming out of the paper. The other half is going into the paper. And it's very pointy. It's very pointy as you get further and further to the right. Does that make sense to you guys? No? Yeah, it's hard. This is like for the visual learners. For you guys that are, so it's like this, but this diagonal that I'm drawing, that is on the plane, is on the paper, on the 2-dimensional. This is flat down here. Does that make sense? And this point is sticking out in the air of the paper. And the other point is underneath the paper, if you count your plane. So, yeah.
Those points are like on the X line, they're like above it, directly over it.
Yes, this point, that one's directly above it, and this one's directly below it. But it's making a spike, like a spiked house, right? Yeah, these are interesting, guys. You can make, if you want to download something called WinPlot, which is what I showed you a little while ago, you can put a whole bunch of shapes. Don't worry, Delta Math is going to help you because it has like the shapes and you can scroll the cursor and make like a whole bunch of stuff. All right, so here we go. I know that area of a square is S squared. I don't want to know that. I want to know it in terms of x. Well, I know that this distance here is 2 square root of x. How do I know that? Because I did it earlier, upper minus lower. So this is 2 square root of x. This point up here is in the top, y equals square root of x. This point down here that I'm making big is at the bottom, the y equals negative square root of x. Are we okay so far, guys? Well, I don't want it in terms of s squared. I want it in terms of x. Is there a way that I can make this in terms of x? Do we know like a theorem or something from algebra or geometry? Hint, hint. Starts with the letter P. Second letter Y. Third letter T. Fourth letter H.
Do we use a special triangle or no?
Yeah, actually, you could use a special right triangle. 45, 45, 90. Way to go, miss. Pythagorean theorem is the one that I was looking for. But yes, you can do 45, 45, 90. S squared plus S squared equals 2 squared of x squared. I'm just doing a squared plus b squared equals c squared. Oh, this point right here, I'm going to call that A, is this point. And this point B is going to call that. A squared plus b squared equals c squared. 2s squared equals 4x. And remember, this is s squared, so all I'm doing is just math here from algebra. So s squared is equal to 2x. So you can see why your algebra, when you were in algebra 1 and algebra 2, why this is so important, guys. All that time that you were in algebra 1 and algebra 2, like, I don't understand why I'm doing this. Well, now, here it is, guys. So my cross section is just 2x. And that's what I would integrate. Cool or not cool?
I mean, I guess we do it, but I don't, if the, like, if the square, if it's still a square, how come the area of the square, first square is bigger than the area of the second?
How come the area of the what? No,
Oh, because the diagonal is longer.
the diagonal is always the long, yeah. And we're adding up the cross sections, right? Like, boom, boom, okay. You good? You sure? Okay. Sorry, miss. Don't hate me, miss. Letter D, the cross sections are equilateral triangles with bases in the XY plane. All right, here's how I do it. Again, I just draw in two-dimensional because I'm not good at three-dimensional. We will do three-dimensional 3D eventually, guys, just not right now. So there it is. There's my 2D model. And here is my cross section. So bam, that cross section is this. Well, I guess I should, let me draw the triangle in blue. And that line in red is this line right here. So it's coming out of the paper. And if you guys were here, I would probably do something like, yeah, it's coming out. Like, it's coming out. Like, you know, like, okay. Godina just looks at me like, okay. All right. Tiff, you're good? Okay. All right. So this distance, we've already talked about it more and more. Like that distance, we already know that expression is just 2 squared of x. Upper minus lower. So that means this is 2 squared of x, this is 2 squared of x, this is 2 squared of x. If you remember from pre-cal, now you might not because we were in a pandemic, but if you remember from pre-cal, we can figure out the area of any triangle by going 2 squared of x times 2 squared of x times half times sine of 60. But if you don't remember that, it's okay. Area of a triangle is 1/2 base times height. Perpendicular height, guys. I need that height. This is 60 degrees. This is 30 degrees. This is a 30, 60, 90 triangle. So that means, let's see, this is square root of x. In a 30, 60, 90, it is n square root of 3, 2n. So square root of x times square root of 3. So that's square root of 3x. So here it is. Area, 1/2. The base is 2 square root of x. And my perpendicular height, square root of 3x. The 3x is inside the radical. Let's see what this simplifies to. A of x equals, the 2's cancel out. Square root of x times square root of x is just x. So I would write that first, and then square root of 3. And that's my cross section, guys. That's what I would integrate if they ask for the volume. How do we feel, guys? Do you want me to show the shortcut one? Okay. If you remember from pre-cal, I'm going to put from pre-cal. You could have done it like this. Area is 1/2 2 squared of x times 2 squared of x sine 60. And we could have gone 1/2 and that go away. Square root of x times square root of x is x. So let's see, 2x times square root of 3 over 2. And look at that, 2's cancel out. X square root of 3. If you remember that, cool. If not, no big deal. All right, guys. Finally, the moment of truth. Do you guys want me to give you guys a head start? No? Okay, we'll go real slow. So I'm going to give you guys, quote unquote, a head start, but we're going to go slow through it. So it says, example 3, this is from the 2008 AP exam. Let R be the region bounded by the graphs y equals sine pi x and y equals x cubed minus 4x. Now remember, you have a calculator as shown in the figure to the right. Find the area of R. It would be nice if you could tell which one's the sine and which one's the x cubed minus 4x without a calculator, but it's okay, you have a calculator, guys. This one, the one on the top, is the sine pi x. How do I know that? Because we took pre-cal, and I can tell you that sine pi is 0, and sure enough, if I plug in a 1 in there, that's sine pi, which is 0. And if I plug in a 2 in there, I get a 0 again. So I know that one for sure has to be sine pi x. The one on the bottom is the x cubed minus 4x. So I'm going to write y equals x cubed minus 4x. I would not change the name because they say y. Sometimes they say f and g. I would not change the name. I would leave them alone. Because they do not give you names, you're going to have to write out the whole expression. This one, letter A. So let's go slow, guys. I was about to. All right, Tiff. Tell me, what do I got to do? No, I really was. I was like, oh, I need to ask because this is a previous concept. How do I find the area R? Like, give me the procedures that I have to do here.
So I think you have interval
You would.
of 0,
Perfect.
and then upper minus order,
Okay, so what do I write first?
sine of pi x minus x cubed minus 4.
Do I just write it like that, x cubed minus 4x? Or do I write like a parenthesis here?
And parentheses right here,
Perfect.
x cubed plus 4.
Perfect. This is what I would write. On the calculator section, do you have to simplify anything? No. This is called, there's a specific word for it. This is called the setup. That's all you have to show. Well, and the answer that you get from the calculator. So that's called the setup. So here we go. I'm going to get my calculator. I'm going to type sine pi x and y1, and I'm going to type x cubed minus 4x and y2. So here's my calculator. I'm going to go to y equals sine pi x and x cubed minus 4x. Ouch. X cubed minus 4x. There it is. I'm going to clear it. So I'm going to push math 9, 0 to 2. And I'm going to go alpha trace y1 minus alpha trace y2. So practice, guys. Practice so you guys can get used to your calculator. If you don't have a TI-84, swing by and I'll hook you up with a calculator, guys. Push enter. Oh, wow. I was not expecting that. I got a pretty number. I just got 4, and that's it. I really wasn't expecting that. I was expecting a decimal with 3 digits afterwards, but that's cool. If you want, you don't have to, guys, but if you want, you can put giant parentheses around those two. They're not going to take points off. It's fine if you do. It's fine if you don't. All right. Letter B. The horizontal line y equals -2 splits the region R into 2 parts. Write, but do not evaluate, so don't waste your time trying to find an answer. An integral expression for the area of the part R that is below this horizontal line. Okay, graph that line, y equals -2. It would look like this. Godinez, I'm gonna need some stuff. What do I need? What they want, guys, sorry, maybe I should have been clear first. They want this region here. What do I need for me to solve for this? You can take your time. Okay, it's definitely going to be an integral. Tell me something before. Yes, I am going to subtract, but before I get there, tell me something about my limits. Is it perfect? That's what I wanted to hear. Guys, you need new limits. You don't have to solve by hand, but you got to show them that you're solving for it. So Chavez, how do I show them when I have a calculator? Like this. This equation here is the x cubed one. So I'm going to write here on the side, x cubed minus 4x. And then this linear line, that horizontal line, is just -2. That's how you show them. You show them that you set them equal to each other. You do not have to show the computations by hand. From there, because it's calculator, guys. If it's not calculator, then you would have to do it by hand. From there, you just write what those values are. X equals, I'm going to have two answers, x equals. So let's go to our calculator. So here's my little calculator. I'm going to go back to y equals. I'm going to turn off y1. And I'm going to go to y3, and I'm going to go -2. Now, I want it to look like this window here. So I'm going to go ahead and click on window. X min, I'm going to go to -0.25. You don't have to. You can make like -1 or something. X max, I'm going to go to 2.25. X scale by 1, yeah, that's fine. Y min, I'm going to go to -3.25. You can go lower if you want. Y max, I'm going to go to 1.25. I guess I didn't have to, but that's fine. And I'm going to push graph. Godinez, how do I tell my calculator to find that intersection? Perfect. Push enter twice. You only have two curves anyways. And then when it says guess, go to the point you first want. So I'm going to go to that one, push enter. 0.53918887 is what I got. Did you get the same number? 0.53918887. 0.53918887. Here's my habits. My habits is this. As soon as I get a number, I store it where? A. I always go down alphabetical. So here we go. Before I do anything, guys, I'm going to store that number. So I'm going to go slow. Ready, guys? Home screen. Second quit. I push X. There's that number. Push the store. It's between 1 and 4. And I go alpha A. So now every time I push A, it's that number. Repeat the process, but for the other one, guys. So let's go back to the graph. I'm going to go second trace, number 5. First curve, enter, enter. When it says guess, scroll to the one on the right. Push enter. 1.67513009. Let's see if I can remember that. 1.67513009. 1.67513009. I hope I got it right. I'm going to store that to B. So let me go back to my calculator. I'll go to my home screen, second quit. I push X. There it is. Store alpha B. So now every time I push B, I get that number. Is everyone still okay? Okay. Here we go, guys. Finally. All right, Godinez. Tell me what I'm going to write on my integral. Yeah, but okay, see this one right here? That is A, and this one right here, that is B, and I'm trying to figure out this area. Perfect. Perfect. X cubed minus 4x. Okay, yeah, you said x cubed plus 4x. That's fine. You can distribute like that. Perfect. There it is, guys. Do I have to solve for it? No. They said do not evaluate. So don't waste time evaluating. Okay, here comes the moment of truth. Here's the good stuff. Letter C. The region R is the base of a solid. So that's the base of a solid, like that paperweight problem. For this solid, each cross section perpendicular to the x-axis is a square. So let me go ahead and erase all this. Just so you guys can see better. So here's my cross section. Where do I want to write it? Right here. That cross section is a square. So what I just did here is my square, and this bottom part is the cross section. That red line is that red line. It's coming out of the paper. It's a weird shape. As you get closer and closer, you have smaller cross sections. As you get close to 2, it's like a little point there. As you get closer to the origin, they start becoming smaller and smaller. All right, what do they want? For this solid, each cross section perpendicular to the x-axis is a square. Find the volume of the solid. Okay. How do I find area of a square? Yeah, S squared. So how do I figure out the length of this side? Just what minus what? How do I figure out the length of this side, guys? This is an expression. Yeah, just the top minus bottom. That's it. And I square that. Does that make sense? That's all I'm doing, guys. Top minus bottom. The top curve is sine pi x. The bottom curve is x cubed minus 4x, and I square that. So I'm going to write a of x for my expression is sine pi x, giant parenthesis, minus little parenthesis, x cubed minus 4x. Close, close, and I put a square. Because area of a square is s squared. I'm putting that for good notes. Do not write that on the actual AP exam. So my volume is equal to integral from what to what? Perfect. 0 to 2. And then I just rewrite that expression, guys. Giant parenthesis, sine pi x, close, minus little parenthesis, x cubed minus 4x. If you want to distribute that little parenthesis, go for it. And then square it. Make sure to put the dx. And then they do want the volume. So I'm going to use my calculator, guys. Remember where you have which one. So here's my calculator. I have sine pi x and y1. So here we go. Math. 9. 0, 2. Open parenthesis. Hey, Mazuka, how do I get y1 in here?
Alpha trace.
Alpha trace. Enter. Put a don't put a square on it yet. Minus alpha trace. Go to y2. Enter. Close the parenthesis. Now put a square on it. And then put an x here. And there it is, 9.978. You can always put more digits, but do not put less. 9.978. Whew. How do we feel, guys? Okay, let me take a sip of coffee real quick. It gives me energy. I mix it pecan with French vanilla, and okay. All right, This one, I'm okay with you guys getting wrong. It's the same concept, but it takes, no, I'm not okay. But for now, until we get more experience. Let's go ahead and do it. The region R models the surface of a small pond. So now it's the surface of a small pond. Okay. For this solid, each cross section perpendicular to the x-axis, sorry. At all points R at a distance x from the y-axis, the depth of the water is given by, so this is how deep it is. Find the volume of water in the pond. Okay. It's okay if you don't see it. It comes with experience, guys. It's the same process. Each cross section is a what? It's not a square, but it's similar to a square though. Now it's not coming out of the paper, it's going in, but it's the same concept. So each how do I find it? Each cross section is a what? It's not a square. No, it's not a semicircle. I have this length, and the depth is determined by this guy, right? So that means right here, right there, let's pretend we're really close to the zero. Right there, I have a depth of almost 3 feet. So it's length times width, length times width, length times width. What? A rectangle. So for good notes, do not actually write this on the day of the AP exam, but for good notes, write cross sections are rectangles, and I'm going to put in parentheses, they go into, or they are behind the paper, right? They are behind the paper. They are quote unquote behind the paper. They're not coming out of the paper. Cross sections are rectangles. It's okay if you miss this one for now. With more experience, you'll get these correct. But I'm assuming that the AP exam is probably going to give you something obvious. Right? They're going to tell you the cross sections are this. All right, so let's see. Volume equals integral. Again, it's going to be the same limits. 0 to 2. And then all I do is width times height, width times height, width times height. So I'm going to write this expression. I have it up there. Giant parenthesis, sine pi x minus little parenthesis x cubed minus 4x, close, times h of x. Since they told me what h of x is, I can just write h of x, dx. There it is. You don't have to do anything by hand. Put it in the calculator. Let me get my calculator again. So here's my calculator, guys. Math 9, 0 to 2. I'm going to open up another parenthesis. I'm going to go y1, so alpha trace y1 minus alpha trace y2. I'm going to close the parenthesis, and I'm going to multiply that. So I'm going to open another parenthesis, and I'm going to multiply that by h of x. 3 minus x. Close. And then put just x in there. And there it is. 8.3699. I would write it truncated. 8.36995. 8.36995. Let's look at the rubric. Let's see how we did, guys. In this case, they don't write units, but sometimes there are points for units. OneDrive, Math Life, Calculus, College Board, Free Response, AB, Scoring Guidelines. We're almost there. There we go. Can you guys see? Yeah, 2008. All right, let's see. It was this one right here. Look at that. 3 points for letter A. We got all three. They're giving you points for limits. 1 point for the integral, 1 point for the answer. Letter B. Why did they choose R and S? Okay, anyways, we chose letter A and B. No big deal. X cubed minus 4x equals -2. Little r is 0.5391. We chose that as little a. And then our little b was 1.675, or big B, it doesn't matter. 2 points. We got them all. There it is. Letter C. Did we get 9.978? Perfect. And then letter D. They wrote the 3 minus x on the front. I think we wrote the 3 minus x on the back. No big deal. We got 8.369. Look, if you round it, make sure to put 3 digits. So a lot of people probably messed up because they put 37 and they didn't put the 0 in there. So if you round it, make sure to put 3 digits, guys. So that's why I always just do truncated. 8.369. Boom, answer, 2 points. So how do you feel? Do you feel that we could have gotten the majority of these points on the 2008 exam? All right, and relax. We've only done one question. You're not going to be a professional overnight. That's why there's a Delta Math, which has assistance. And then I'm going to put later on today a handout activity. But I didn't want to put the handout activity right now because I wanted you guys to get practice. So let me come back. You guys are already here, so let me come back.